Wireless overlays in which coverage of more than one wireless technology is available at a certain spot are becoming more and more common. For instance, at home one may have UMTS, WiMAX, wireless LAN and Bluetooth coverage, as well as access to a self-organized wireless mesh network. In an ideal scenario, the best access network should be dynamically chosen according to various network and user level parameters. It is in this context in which vertical handoffs appear, and their goal is to seamlessly transfer an ongoing communication from one access network to another. This video presents an example of SIP mobility in a 3G wireless LAN scenario, built over the extreme testbed of the IP technologies area of the CTTC. The goal of this demo is to transfer an ongoing voice communication between a 3G and a wireless LAN network by means of SIP signaling. So a heterogeneous networking scenario was built over the extreme testbed. The UMTS network consists of a Nokia Siemens Networks Node B and emulated RNC, SGSN, GGSN and HLR by means of a commercial UMTS network emulator. Additionally, some general-purpose nodes of Extreme were configured to act as SIP server, wireless LAN access point, mobile node, and correspondent node. In this scenario, mobility is handled by the Session Initiation Protocol, or SIP for short. The K-Phone voice over IP softphone, whose signaling is based on SIP, was modified so that, when executed in a mobile node, it sends to the correspondent node the new IP address through which it should be reached. And this is done in the middle of a call when the user decides to switch to the other access network. And now let's see how it works. What we see in this graph is the evolution of the throughput with time in each of the interfaces of the mobile node. As we can see, right now it is 0 in both interfaces because we have not yet established the voice over IP session with the correspondent node. When we start the K-Phone application, it registers the IP address of one of the interfaces of the mobile node in the SIP server. In our example, it registers that of the wireless LAN interface. And the same happens in the correspondent node. Now, the correspondent node is calling the mobile node, and the mobile node answers the call. As we can see, the voice flow starts flowing through the wireless LAN interface of the mobile node. This throughput is that of a GSM codec plus the corresponding overhead. And the throughput through the UMTS network is still 0.
2 blue fish swam in the tank.
Tea served from the brown jug is tasty.
Now let's switch to the UMTS network. The handoff time is small enough to make the glitch in the voice flow received by the mobile node almost unperceivable.
The ship was torn apart on the sharp reef.
And now let's see what has happened with the throughput in both interfaces. The UMTS throughput is now different from 0, while that of the wireless LAN is 0. And now let's move back to the wireless LAN. As expected, we have the opposite behavior of the throughput.